Hello and welcome everyone. Thank you for joining our webinar for supporting development of quantum and superconducting applications. My name is Nat Stevens. I'm the Director of Marketing with Ardent Concepts. Obviously, these are strange and unprecedented times, so I'm recording here from our home office, but we wanted to still make sure that we could support our marketplace with some of the novel approaches we're taking to quantum and supercomputing and to walk you through them today. A bit of housekeeping before we get started with the presentation. Today's session is scheduled to be about 30 minutes long with some time for questions at the end. If we don't have a chance to answer your questions, and please do submit them into the polls or the questions box in the GoToWebinar Hangout, we will follow up with you or have an applications engineer follow up with you to answer those questions for you. We look forward to supporting you in the customization of your quantum and superconducting apps. And with that, we'll go ahead and get started. I do want to make a note that all attendees are on mute. So please, again, use that questions box as we move forward. So what's the purpose of today's webinar? It's understanding how Ardent can support the development of those quantum and superconducting applications. And the reasoning is because the newest form factors of Ardent's products support the unique challenges that quantum computing causes for engineers today. Things like density, substantial environmental changes, and an increasing need for more high-speed lanes are causing quantum computer designers to rethink traditional routing methods of individual cables. And by utilizing superconducting materials like cupronickel cables and the existing patented contact technology that Ardent's known for, engineers are able to drastically decrease real estate required by individual connectors and increase their channel count while they're able to improve the signal integrity within their systems. So some key takeaways that we hope that you get from today's webinar is that Ardent offers one of the densest solutions on the marketplace today. We're able to actually fit 168 or more coaxial lines through a single ISO 100 flange. We offer a qualified hermetic feed-through, 50 ohm hermetic feed-through from room temp to vacuum. We offer industry-leading crosstalk at a 2.54 millimeter pitch, signal to signal. The ability to utilize preferred cables within the industry. So not just our flexible cables that come standard on our TR Multi-Coax, but also customized cabling solutions like cupronickel or niobium titanium. We offer some completely non-magnetic assemblies. So depending on the level of magnetism that your system can handle, we can offer customization in our assemblies. And we offer socket solutions for quantum integrated circuits. And we'll take a look at that in some of the subsequent slides. So the focus of today's webinar is mainly on our TR Multi-Coax series product and how it relates to the quantum superconducting applications. Our TR Multi-Coax product is a compression mount multi-port cable assembly for carrying high-speed signals with true 70 gigahertz performance, and it's the highest performing solderless connector solution on the market today. So compared to traditional solder-down coaxial connectors like SMAs or SMPs, TR Multi-Coax can offer you about an 80% space savings on isolation disks and is easily reusable. So it can be moved from position to position on a disk or on a footprint without the need for any surface mount components. So unlike traditional connectors where you have a cable and connector that mate to a connector on an ISO disk, this can mate directly to either a footprint on a PCB or directly through an ISO disk. So some key applications for the TR Multi-Coax connector are in dilution refrigerators, shielding cans, sample exchangers, between isolation disks, and from dilution refrigerators out to measurement equipment. And quantum computing customers use TR at millikelvin cryogenic temperatures with superior signal integrity, with custom cupronickel or niobium titanium cables, in dilution chambers, shielding cans, and or sample exchangers to simplify cable issues and routing issues in these constrained spaces, as a denser, hermetically sealed connection solution between isolation disks, and non-magnetic assemblies are being built upon request. Understanding the TR Multi-Coax connector technology is founded in understanding our compliant pin contact technology. So this is Ardent's patented technology. And we offer this in two form factors, our spring probe and our connector compliant pin contacts. These contacts offer an extremely short electrical path. And in doing so and building them into our assemblies and into our products, we give customers the access to a very high signal integrity product in a very, very short electrical path. They do that by offering scalable solutions down to a very, very tight pitch. And with both of these contact sets, the magic behind it really falls within the ability to compress these contact sets, causing those coils to wipe on themselves and therefore behaving like a solid contact element in a very short electrical path. Now, many people think that the top one, that spring probe conductor, would behave like an inductor, but in fact, when that coil is compressed, those coils actually wipe on one another. That wipe action causes it to behave like that solid contact element. On the bottom contact set, the connector, you can see there's lancers on the ladder style contact, and again, the same thing. When that contact is compressed, those lances touch onto the beam below them and create a very, very short electrical path for these contact sets. And these contacts go into all of the products that Ardent offers today. A bit about the TR Multi-Coax product itself, which houses these electrical contacts. The TR Multi-Coax is comprised of a ganged cable assembly. So you can see on the top side here, coaxial connectors are available. This could be a SMA connector, a 2.54 millimeter signal pitch to pitch, 2.92K connector, or a 1.85 millimeter connector out to 70 gigahertz. We offer a standard coaxial cable. That's an 047 diameter cable, flexible cable, which allows for room temperature escape of multiple signals out to the instrumentation on the room temperature side of a dilution refrigerator and a cryogenic system or quantum system. And then those cables are ganged into a block assembly, and the contact sets themselves, the proprietary contacts that we speak about, live in our interface assembly. That interface assembly we'll look at in the next slide actually houses those contact sets. So from a component customization standpoint, the Multi-Coax product, our TR Multi-Coax, is available in a variety of channel counts and customization. Our standard channel counts offer you 4-channel, 8-channel, 12, 16, and 24-channel variations in a variety of frequency ranges up to 70 gigahertz. It's also important to note that they have some multiple mounting styles. So the cables can escape vertically in our straight mount option, and we also offer a low profile right angle version of the connector. And this Z height limited connector is great for escaping in very confined spaces, for example, within a sample exchanger or out right from under an IC. The TR Multi-Coax interface assembly is what houses our compliant pin technology. And in this case, you can see that the compliant pins are actually sandwiched between two plates in a coaxial pattern with ground surrounding those signal contacts. And so that shielding, those ground shieldings, offer us a very, very, very low crosstalk within the system. And this is really key, obviously, as we're looking to scale down through dilution refrigerators to make sure that the radiation out from the connector and between signals is not disturbing the quantum bits. From an electrical standpoint, an electrical performance standpoint, it's important to note that our TR multi-coax connectors today are used in applications out to 70 gigahertz, and we're actually in development for beyond that out to 110 gigahertz today. Now, granted, I understand that that's typically overkill for the quantum computing marketplace, where traditionally signals up to 18 gigahertz are what's required, but certainly those bandwidths are intended to be pushed out moving forward. And as we start to look at that, there's some headroom with the TR multi-coax connector that allows you to expand those bandwidths. Some key points to look at here: the -1 dB point of a TR multi-coax assembly with 3 inches of cable is at 27 gigahertz, so well past the traditional 18 gigahertz that quantum applications may be supporting and beyond. And then the return loss never exceeds -17 dB out to 70 gigahertz as well. So a very, very clean performance within the connector. And within our crosstalk, you can see that actually this is pretty much at the instrument floor of our instruments in our system for our crosstalk between signals in the multi-coax connector. So very important to note that these signals are very, very clean as they travel down through your system. So how does the multi-coax connector enter a dilution refrigerator? We do so using our patented 50 ohm hermetic feed through. So this is a leak-proof feed-through design. So there's a max leak rate there. And essentially this has been used and pulled under vacuum in dilution fridges and vacuum systems to show that it's completely leak-proof. And this 50 ohm hermetic feed-through design allows us to stack multiple feed-throughs in a single isolation disk, allowing you to bring in or escape up to 168 or more channels through a standard isolation disk, depending on the layout of those hermetic feed-throughs in the system. This allows you to easily mate or demate multiple TR multi-coax systems and multiple high-speed channels. So in the image in the top right here, you can see we actually have um, 10 of our 16 channel hermetic feed-throughs. We also have a system in circulation today that uses 7 24 channel feed-throughs in line through the system. So a bit about the signal integrity performance of the 50 ohm hermetic feed-through. On the right here, you can see a very linear insertion loss of the feed-through, which never actually exceeds 1 dB out through 40 gigahertz. And the return loss never exceeds minus 10 dB out to 40 gigahertz. But at the frequency of range up to 18 gigahertz, you'd see we hover right around minus 20 dB out to 20 gigahertz in that return loss. The crosstalk, again, is very, very good near the instrument floor through the hermetic feed through, and that's designed through our shielding process and through the proprietary nature of that hermetic feed through. So then once we're in the fridge, the TR multi-coax system offers a plethora of options and customization down through your system. And we acknowledge that looking at different quantum systems and different superconducting and cryogenic systems, many of them are in experimental stages and need the advanced customization that a product like TR Multi-Coax can offer. So this is a key point of differentiation for the TR Multi-Coax product in that we're able to use flexible copper nickel niobium titanium cables and a variety of different cable assemblies, which we'll look at on a following slide. We can offer channel count configurations. So depending on the need to scale up the number of qubits from a very low number in the tens to hundreds or thousands, there's the ability to scale up those form factors for the TR multi-coax connector. And custom cable lengths are easy for us to do. We also have in-house cable bending equipment that will allow us to create unique bends in the cable system for exact bend science within the system itself. From a thermal anchoring standpoint, we can build into our connector sets and into our cable sets options for thermal anchoring to minimize the heat load in the cryostat and to ensure that you have proper thermal anchoring out through the system as you go between stages. In this case, on the right-hand side, you can actually see a full system that was built from the top of the room temp side of the dilution refrigerator all the way down to where the shielding can or the sample exchanger would be loaded in. And through this, we have different various stages of thermal anchoring. And we're also looking at what types of attenuation options might be available for inline attenuation of -3, 6, 10, and 20 dB. And so we're working with some partners today to build in attenuation within blocks that would allow for cables to mate to one another with inline attenuation. From a cable and non-magnetic standpoint, as I mentioned, Ardent offers multiple form factors of our product and varying degrees of non-magnetic options. So depending on the tolerance of magnetism that your system can handle, we can start to swap out certain materials within the multi-coax connector to reduce the magnetism. So you can see here we have actually a column which has our standard TR materials on the left-hand side, and then varying degrees of removing magnetics throughout the system. So we actually have three different M1, M2, and M3 tiers, which allow us to make the connector and the TR multi-coax fully non-magnetic. So I think it's important to note that while this is a top-level presentation, these slides will be shared following the presentation for review. And we always encourage you to contact our applications engineering team at support@ardentconcepts.com for questions regarding the customization that we can do with our TR multi-coax connector. Additionally, we talked about different cable options that are available through the multi-coax connector within system and different cable properties. So 3 common cable types that we have used within our systems are silver-plated copper nickel, and niobium titanium copper nickel. And so we can certainly supply you various cable sets and based on your requirement can help build the connector to your specifications. There are other cable options available as well. These are our three most common that I would say, but certainly contact us today if you have other thoughts on cables you'd like to use. We like to think of ourselves as cable agnostic as we build our connector sets and to ensure that we can support the system that you require. As we move our way down the dilution refrigerator, we think about the different varying stages, and we've taken a look at how do we bring our TR multi-coax into the connector using our hermetic feed-throughs, and how do we continue to wire down through the system. Once we reach our final stages of the dilution refrigerator or cryostat, we start to look at where the actual quantum IC lives, and getting into that quantum IC, whether it's through a sample exchange or a sample loader, or whether the chip itself is a bare die and we need to touch down on that bare die. Ardent offers quite a few different options in this space as well. And so I wanted to highlight a couple key areas in which we've found our way into the sample exchangers. This is a good example of a sample exchange which gets loaded in. It's a quick sample exchange, which is nice so that you can actually have to not bring the dilution refrigerant back up to room temperature. But in this case, you have a near chip solution. So the chip lives on a PCB within the sample exchanger. And we actually have our TR right angles and our leapfrog connectors that touch down on the PCB footprint directly next to the chip. So you're getting very, very close to the device under test. And then those TR multi-coax connectors are wired out to the outside frame of the sample exchanger. In some cases, we have customers wiring out to SMPs that are pluggable, or more preferably, and probably a simpler solution, is to route the multi-coax connector to a blind mate multi-coax connector, so the TR interface on either end of the connector, which can then be mated to a TR outside of the sample exchange. And in this case, it's a higher density interface. So you can see on the right-hand side of this model, there's actually multiple SMPs that are designed into the outside of that scope. Those could be replaced with a much denser interface of the TR multi-coax interface. At the chip level, we offer customizable coaxial sockets for the quantum processors themselves. So this is actually going to leverage the same type of technology that's used in the TR multi-coax interface, where there's a brass interface, which has shielded ground contacts around the signal pins. And this gives you density as tight as 0.8 millimeters signal to signal. And this coaxial approach is going to minimize crosstalk at the device level. So with the screw down lid, the bare substrate processor mounts right within this socket and will allow you to route signals out. And you can do that using the TR multi-coax connector that we saw in the previous slide. For even denser and tighter pitch packages, we've offered a tight pitch 0.4 millimeter pin to pin socket for a bare die substrate. In this case, the socket body is actually machined out of anodized aluminum to improve the isolation within the device and within the signals of the device. And spring probes are plated in gold only to remove the magnetism. So our nickel plating is omitted from that process in this case on the spring probe contact sets. And this gives you basically a very, very tight pitch socket solution for the quantum devices, a small quantum die. And in this case, the bare die itself aligns using dowel pins, you can see here. And the customer in this instance provided a lid for compressing those parts. Ardent does have the capability to work with you to provide a lid and provide a lid for you, but we certainly are understanding that with certain proprietary restrictions, that may not be possible in all instances. So that summarizes some of the high-level um, opportunities that we've had to work with customers in the quantum space and some of the key products that we've released into the marketplace today. We wanted to kind of give you just a brief overview of understanding some of our capabilities with an understanding that there's obvious customization that can be done within each of these products. As I mentioned, quantum computing is oftentimes in experimental stages, but what this does allow you to do is scale up the number of lines for commercial applications and for mainstream applications. And that's been the key focus of the TR multi-coax product within the quantum computing industry. And so, with that, we'll take a couple minutes for some questions as we start to round out the end of our presentation. And I will go to the questions box now. It looks like the first question we had is, what's the highest channel count that you offer in the TR Multi-Coax product? So that's a great question. And I think I can answer this two ways. The highest channel count that we've built into a system today is a 24 channel TR multi-coax. And within that isolation disk, there were actually 7 of those feed throughs. So a total of 168 channels were available within that. That said, the nature of the TR multi-coax product allows us to scale up that coaxial block beyond 24 channels. So if it were required, we could actually do more than that, and certainly could scale up further. One of the nice things is that traditionally these dilution refrigerators offer multiple ports and lines of sight through the system. And so by allowing you to reach 168 channels through a single port, that's nearly, I would say, quadrupling or more the standard connection method today with SMAs or single individual connections. So there's another question here. Looks like Cooper nickel has a relatively high RF loss. Are there other non-superconducting materials available? Beryllium copper, brass, copper cladded steel. So that's a great question. I think that one of the things we like to point out here is that we're cable agnostic, and even with our contact sets themselves, we're continually looking at what type of superconducting plating we can do, what type of cables are required to mount the system. So I don't think that what we saw here in the presentation today is the be all end all. I think that we're willing to work with a variety of different materials within the system without having to change very much in our process and how the TR multi-coax connectors are built. And I think that level of customization is what plays into our success in this marketplace today. Is that we can certainly work with a variety of multi-coax cabling and different superconducting materials, and the technology itself, the spring probe and connector technologies, lend themselves well to a variety of different options. And so, we encourage you to reach out to us and let us know the challenges you're facing, and we'll certainly do our best to approach the problem with a solution that will work, that we can help you with. Okay. I hope that answered the question for you. Let me move on to the next question here. So it looks like, have you ever built a system for touching down and probing directly onto the die itself? That's another great question, and I didn't show it in the slides here today, but certainly can send out some additional materials. We have actually built probing solutions which utilize the same interface technology and cabling technology as the TR multi-coax at a tighter pitch using an 034 semi-rigid cabling, which can touch down directly onto a bare die substrate at a much tighter pitch. And so we have some drawings that we'd be willing to share and start to distribute that show how we've done that. It's kind of a unique pattern because it actually routed those semi-rigid cables out to a circular pattern to mate right within the shielding can. So it actually was able to be built right into the shielding can and touch directly onto the chip. So there's some neat stuff we've done there, and certainly those resources can be shared if you'd like. It looks like, we have one more question here, which says, oh, interesting. The question was, how long can the cables outside on the room temp side of the dilution refrigerator be? Our instrumentation is located far away from the dilution refrigerator. So that's a great question too. We actually have customers today who have that flexible cable outside of the dilution refrigerator, as long as 2 or 3 meters. The caveat that I'll say with that is obviously there's additional loss, per inch, per foot, per meter of that 047 flexible cable. But our understanding is that the tolerance in that loss is acceptable at the lower frequencies that quantum computing is currently at. So one thing that we've seen is that if a customer wants, they can have that very long flexible cable, but we are also willing to work with them to make a short cable escape right from the top of the dilution refrigerator through that hermetic feed through. And then oftentimes customers will use a thicker a VNA cable or high fidelity cable that mates to the TR multi-coax connector end. We're flexible in either option and certainly want to support the customer base. So we can we'll do what works best for the customer. I think that if you wanted to, there are some systems out on the marketplace today, some dilution refrigerator manufacturers utilizing the TR multi-coax connector. And I'd encourage you to go do some web searches for that today that have a longer cabling, a longer multi-coax connector cabling that comes out through the system. So with that, it looks like we're rapidly approaching our finish time. I want to thank everyone for joining me today. I know that it's a little bit more difficult as we're all scrambling and working from home, but we hope that you took some value away from today's webinar. As always, we encourage you to reach out to our technical team, our applications team at support@ardentconcepts.com. They can certainly get a better understanding for the challenges you're facing in your applications and the existing solutions we've put in place to help. But we also look forward to the ability to take on novel challenges that you're facing today as designers look to scale up well beyond 100 or 1,000 qubits. These challenges are only going to increase, and we think that the TR multi-coax product, along with our Coaxial sockets and socket products, will help the quantum development for the future. With that, I'll let everyone run today. Thank you again for your time, and have a great day.
Thanks for watching. Please don't hesitate to contact us for help solving your application challenges.